Question 10 asks us to find k if kx squared minus 10x plus k minus 1 equals 0 has two distinct real roots. So we know from our notes, if we have two distinct real roots, that means that the discriminator has to be, I'm going to call that d, has to be greater than 0. And so our discriminator is this expression, b squared minus 4ac. So we know that if this has to be true, then b squared minus 4ac has to be greater than 0. And so now we can plug in what b, a, and c our coefficients are for this equation. And so b is our coefficient on x, so it's negative 10. And we have negative 10 squared. And a is our coefficient on x squared, so it's k. And c is what we have at the end, so it's k minus 1. And that's all greater than 0. So I'm going to start just by evaluating this out a little bit. Negative 10 squared is 100. And I have 4k times k minus 1. So multiplying that 4k in, you get negative 4k squared plus 4k is greater than 0. And so I can simplify this down further by dividing both sides of my equation by 4. 4 goes into 125 times. This simplifies down to negative k squared. This down to just k. And on the right side of the equation, 0 divided by 4 is just 0. And so I want my coefficient on k, on this k squared term, to be positive, because that makes it easier to solve for it. And so I'm just going to basically multiply both sides of my equation by negative 1. So I'm multiplying this whole thing by negative 1 and 0 by negative 1. And so on the left side, that gives me positive k squared minus k minus 25. And since I've been multiplying by a negative, I have to switch the direction of my inequality sign. So this is going to be less than, and 0 times negative 1 is just 0. So what I have here is I'm trying to solve for k, and this isn't easy to factor. So what I'm going to do here is use the quadratic formula to solve for k, just like you do if this was just a regular quadratic equation that you were solving for x. So what I'm doing is, because I'm trying to solve for k in this quadratic function, and so I'm looking for when my y values are less than 0. So imagining this as a quadratic formula, sorry, a quadratic function, we have something kind of like this. You know it opens upwards because our k squared term is positive. And so we're looking for when this whole thing is less than 0. So that's this area here, below the x-axis, is what we're interested in. Sorry, to label this better, x in this case is k. So we're looking for the values of k for this section of the function below the axis, because that's less than 0. And so to figure out what values of k work here, we want to look at what points here does the function cross the axis. Or in other words, where is, for what values of k is y equal to 0? And so to do that, I'm going to pretend that this is not an inequality, because I'm looking at when this is equal to 0, and that's these points here. And so in this case, like I said earlier, what we want to do is use the quadratic formula, and that is k or x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So that's the way we can find our two values for k for each of these 2 points. And in that way we can figure out all the values for k in between these 2 points that make this equation true. So plugging in this case what our coefficients are, we have b is the coefficient on k here, so it's -1. So it cancels out this negative and we just have a positive 1. Then we have plus or minus b squared is again -1 squared, which is just 1. 4a is just 1, it's the coefficient on k squared. And c in this case is -25. And this is over 2 times a, which is 2 times 1, so it's just 2 on the bottom. Okay, and so simplifying this down, we have 1 plus or minus 1 minus 4 times 1 times -25 is -100, but we have this negative sign out front, so that cancels out, and we have a positive 100. And so we get k is equal to 1 plus or minus square root 101 over 2. And so this gives us the two values for these points here. It's going to be k1 is equal to 1 plus square root of 101 over 2. k2 is 1 minus the square root of 101 over 2. But if we remember, what we really have here is an inequality, and we're looking for basically all the values of k in between these 2 points, because those are the values of k where this function is negative. So we're looking at everything above, greater than this point and less than this point. But to figure out which one's which, we can look at what numbers we have here and figure out which one's smaller and which one's greater. So square root of 101 is going to be around 10. And so 1 plus 10 is around 11, divided by 2, it's around 5. In this case, we're taking 1 minus 10, so that's -9, divided by 2 is around -4.5. So k2 is our lower point here. It's going to be the -1, and k1 is this point up here. So for an equality, we're saying that k has to be greater than 1 minus square root of 101 over 2, and k has to be less than 1 minus square root of 1 plus the square root of 101 over 2. So I believe in the answer key they might have gotten these switched around, but you can evaluate this out in your calculator to convince yourself that it should be in this order, and it is all the values of k in between these 2 points that make this statement true in the question. So these are our answers for k for question 10.